Hello everyone. We're going to discuss about mathematics in medieval Europe. While China, India, Islamic societies flourished mathematically, Europe experienced a scientific and intellectual stagnation during the Dark Age. Scholastic focus prioritized humanities, however, Persian and Middle Eastern scholars like Al-Khwarizmi and Al-Kharazi made significant mathematical advancement, including contribution to spherical trigonometry, algebraic notation, and algebraic geometry. During the medieval period, there was a tool are used for solving, and this is called abacus. And this is abacus looks like. Abacus is an ancient tool used for counting and performing mathematical calculation like basic operation of addition, subtraction, multiplication, and division. In every layers, they have own represent values. The first layer is tens, second layer is hundreds, thousands, 10,000s, 100,000s, 1,000,000, 10,000,000s, 100,000,000s, and maximum of billions. The abacus are traditionally made with frame that holds wire or rods on which movable braids are placed. And also guys, abacus are the first tool that used for solving. From the 4th to 12th centuries, Europe mathematical knowledge was limited, relying mainly Boethius' translation of Greek word and using the efficient Roman numeral system. Increased trade with the East in the 12th century brought Eastern knowledge including translation of Al-Khwarizmi algebra, Euclid elements to Europe. Leo Pisano, also known as Fibonacci, wrote a Liber Arabici, book of calculation. Amat promoted the use of Indo-Arabic numerals, the numbers we use. While it wasn't printed until the 19th century, it's famous for introducing Fibonacci sequence, a pattern of numbers where each number is the sum of the two preceding ones, like 1 plus 1 is equal to 2, 1 plus 3, 2 plus 3 equals 5, and 3 plus 5 equals 8, and so on. The book also covered algebraic methods and used a horizon for fraction, although it kept some older ways of writing fraction as Leonardo of Pisa, now known as Fibonacci, serendipitously about the Indo-Arabic numerals on a trip to what is now Bahia, Algeria with his father. Europe was still using Roman numerals. Leonardo wrote Liber in 1202, updated 1254, introducing the technique to Europe and beginning a period of popularizing it. Book also brought to Europe known as the Fibonacci sequence. Combinatorics is very called areas of math dealing with counting arrangement. Even ancient texts like the Rhind Papyrus shows example it's involve figure out how many ways things can be arranged, like the different outcomes when rolling dice. Jewish mathematician in the Middle Ages such as Rabbi Abraham ben Meir in Israel and Levi ben Gershom were especially interested in these kinds of problems. Bhaskara's Livati, named after his daughter, an Indian math book, include algebra and combinatorics problems, the study of counting, arranging things. These problems often show up in games and puzzles. One important concept in combinatorics is binomial coefficients, often shown in Pascal triangle. While Blaise Pascal is famous for his work on probability in the triangle, the idea was around much easier as seen in Bhaskara's works. Fibonacci, known for his famous number sequence, also contribute to combinatorics with his rabbit problem, which explores how many rabbits you have after certain amount of time. While Europe focused on religion and farming during the Middle Age, the Islamic world saw the flourishing of science and mathematics, including the development of algebra. The algebra itself comes from the title of a book by Al-Khwarizmi, Kitab al-Jibra wa al-Muqabala, which explain how to solve equation by moving terms around to find the unknown value. Omar Khayyam, a Persian poet and astronomer, also made significant contribution to algebra. His work on cubic question, finding solution to equation with x cubed, complete around 1079, was groundbreaking. He also discovered a relationship between binomial coefficients number in Pascal triangle. Centuries before Pascal, his mathematical achievements weren't widely known in the West until relatively recently. Girolamo Cardano's Ars Magna 1545 was a major advancement in algebra, solving cubic and quartic equation with x cubed and x quartic, while Cardano used letters for known values. Frasco's Vitae later revolutionized algebra by using letters for both known and unknown quantities. Weight notation made it easier to understand solving equation as finding the values of x that make a function equal 0, laying the groundwork for modern algebra, trigonometry, and calculus. People have used step-by-step problem-solving methods for centuries. Euclid, around 300 BC, had one for finding the greatest common factor of two numbers, and 1900 David Hilbert wondered if a single algorithm could solve very mathematical problem, and Turing later created the idea of a Turing machine, a simple theoretical computer that could solve any problem given the right instruction, which is basis of modern computers. He is the first inventor of Turing machine. A fundamental model of computability was the British mathematician and logician Alan Turing. And this is Turing machine looks like. A Turing machine is an abstract computational model invented by Alan Turing that is consists of an infinite tape, a read-write head, and a set of rules that determine the machine action, allowing it to simulate any algorithm. Turing machine is primarily used to explore the limits of what can be computed and to understand the foundation of computer science, particularly in proving theorems about computability and computational tractability. Kinematics is the study of motion. By the end of the 12th century, the works of Aristotle on the subject were being introduced into Western Europe frequently via translation from Arabic and Hebrew intermediates. Nicole Oresme in 1320 to 1382, a French mathematician whose work anticipated many of them develops of the next few centuries. In the particular, Oresme come up with the idea of representing motion by a picture. Nicole Oresmes' work significantly influenced Galileo. While Galileo challenged many scientific ideas of his time, he appreciated Oresmes' use of graphs to represent motion and used similar techniques in his own writings for both scientists and the public. And that's all. Thank you for watching, guys, and I hope you have learned something new. Bye bye.